That's me. My name is Torsten Strauss. I'm a German MVP for data platforms since a while, specialized in performance tuning. And I'm going to present parallelism in SQL Server, which is definitely not a very easy topic. And I'm sure I cannot cover everything within 1 hour. But I hope at least to give you an idea about the benefits and also the flip side of parallelism. So overall, I would say parallelism in an OLTP system is not a very good idea. And parallelism in a data warehouse system is definitely something you will see and you benefit from. So maybe this is the overall summary. And let me switch to my demo code here. So before the presentation, I already prepared a few tables, nothing special about them, just to populate a few big tables in order to make sure that we have enough data in a table so that SQL Server considers parallelism, because otherwise the estimated cost for an execution plan is too less that we will reach the cost threshold for parallelism, something which we will see later on. That is the reason why we have a few tables, and maybe I do not even use them later on. It depends how far I can go, but that's it. Yeah? So nothing special. So let's talk about parallelism. So what is parallelism? So the idea of parallelism is that SQL Server can execute queries using multiple CPUs or cores, yeah, at the same time. What we will see is that parallelism, as mentioned already, is not a very good idea in an OLTP system, so online transactional processing, so like an ERP system, for example, because parallelism produce an overhead, which we will see especially on the weight type CX package. So class exchange packet is a weight type we will see later on. So we will also understand that we have a so-called coordinator thread, which is thread 0, which have to coordinate all the different threads running at the same time, which is, again, an overhead. And this is something which we have to take into consideration, which will definitely slows down the overall query. Okay, so I would say, as mentioned already, parallelism is sometimes good, sometimes bad. And as an escalation, we will see that SQL Server has something, or we will see something like thread pool starvation. That is a situation where SQL Server do not have enough worker threads available, so that the worker have to wait for an idle worker thread before the query execution even can start. So whenever you see a thread pool starvation, it is very likely that you have a high number of queries running in parallel. And it is definitely a good idea to either increase the cost threshold for parallelism, something which we will see in a minute, or implement the right index strategy in order to make the execution plan cheaper. So to reduce the cores SQL Server considers during execution of the query. Yeah? So thread pool starvation is definitely something you do not want to see in any kind of system, right? So again, it is also worth to mention that there is no guarantee that SQL Server will run a query in parallel. So there are several operators, as we will see. SQL Server cannot execute these operators in parallel. A good example is a top operator, for example. And so sometimes you wonder why the query estimated cost is definitely very high, but the query is still running serially. So this is something you have to understand. There is no guarantee, right? So let us try also to understand what kind of pre-requirements we have to fulfill that SQL Server considers parallelism. So first of all, SQL Server must running on a multiprocessor, multi-core, or hyper-threaded machine. I mean, in nowadays, this is very typical, I would say. So processor affinity configuration must allow SQL Server to use at least 2 processors, something which we will see later on. A very common mistake people are doing. So that is the reason why I guess it is definitely worth to present a specific trace flag, which we have to set here. So the maximum degree of parallelism, so the advanced configuration must be set to 0 or more than 1, because otherwise the overall instance, and this is something which we can do on a database level since 2016, I guess, as well, is limited to use only 1 core. So we can always overwrite the behavior by a specific query hint, something which I will show. Very common for SAP environments. So SAP internally benefits from multi-threading or parallelism. And when a user executes a query, it will be run just on 1 core. I mean, it's a very nice idea from SAP to get the most of the system for the internal processes. But whenever the user wants to benefit from parallelism, this is limited by the DOP, which is set on the instance level, right? There's a specific feature, I call it a feature, honestly, I do not know whether this is the right word or not, called Resource Governor, which is available in Enterprise edition only, where you can also the limit of, where you can limit the maximum degree of parallelism. So the cores which can be used by SQL Server by a resource governor workload group, something which we will see later on, because I guess there's a smaller bug. So something I guess it is definitely worth to understand. And as mentioned already, so the overall decision whether SQL Server will run a query in parallel or not is depending on the estimated subtree cost. And again, it is the estimation. We will never ever have the actual cost of a plan. That means the estimation, the estimated subtree cost of the overall plan is highly dependent on your cardinality estimation. That means when your statistics are stale, you do not get the right estimated number to be reached, and therefore SQL Server, it is very likely that SQL Server will not select the right operators or iterators. It depends how you want to name it. And it will also either consider parallelism, even parallelism makes no sense, or the other way around, right? So, I mean, it is definitely worth to make sure that your statistics are up to date. Again, otherwise it is very likely that you use a non-optimal plan. Okay, let's go through some of the pre-requirements I mentioned here. So let's go down, and first of all, whenever I would say have to tune an instance, it is not important whether it is an on-premise one or an Azure VM or managed instance or whatever, or even a SQL database, Azure SQL database. So I would like to understand what kind of CPU is currently operating on the host. So on my machine, this is my personal machine in front of me. I would say just a laptop. I have just one physical CPU, which is not very surprising, but it is hyper-threaded. So that means I have an 8-core CPU in my laptop. Okay. So and again, if I do not have more than one physical CPU or more than one core, SQL Server cannot run queries in parallel for sure. So processor affinity, something which we will cover in 10 minutes, I guess, even a little bit more in detail. But first of all, I will start simple. So the processor affinity is something which we can set on an instance level. And just for those of you who prefer to work with the GUI instead of T-SQL, so I'm currently talking about the processor, I would say, affinity mask, which you can define here, or you can do it with T-SQL, which is always much better because some of I would say some of the constellations you cannot configure with the GUI. You only can do it in T-SQL. That is the reason why I always prefer to use T-SQL. But nevertheless, you can see I have one physical core, one physical CPU with 8 cores. So it's 0-based. That is the reason why the first core is named CPU 0. So, and what I can do is, for sure, I can limit the number of CPUs which is visible for SQL Server, which definitely makes sense sometimes when you have more than one instance running on the same host, because then you can already, I would say, balance the workload and avoid contention, because you decide that one instance on the same host can only use processor, I don't know, 1 up to 4, and the other instance only can use processors 5 up to 8, yeah? Or you can even unbalance the use of CPU. Nevertheless, this is a very, I would say, handy approach, and it only works with SQL Server, because it will not work with SQL Server and analysis services or whatever you have installed on your machine additionally to this server, because most of the other services are not processor aware. It means you will limit the number of CPUs SQL Server can see and use, but the other service which is running on your host can definitely use all of CPUs, which again is, I would say, just limits SQL Server, no? But you do not avoid CPU contentions that much. So just want to make sure that everything is working here, and we can see from the configuration perspective, that is exactly what I want to see. Cross threshold for parallelism is set to 5. Maximum degree of for parallelism is set to 0, which is, by the way, the default configuration. So let me check the affinity mask, and depending on whether you have you're running on you have more than, I guess, 32, yes, 32 processors. Either is the affinity mask, or if you have more than 32 processors, you will see the affinity 64 mask. Yeah? So it is not, I would say, about the architecture, it is a number of processors you use. Okay, so I will run this query here in another window and make sure that I discard the result after execution, because otherwise we will wait forever. Sorry, discard result after execution. And let me do this. And I will also enable the execution plan here to see the final execution plan. So, and by opening the properties of the query, we can see the degree of parallelism is 8. And that's exactly what I wanted to see. So SQL Server can use all 8 cores. So now I'm going to limit the number of CPUs by the affinity mask, and just, I would say, limit the use of SQL Server, or the other way around. SQL Server can only use CPU number 3. Again, it is 0-based, but it can only use one CPU, one core. So we can see now from this configuration that the value which is in use is 4. For the first, we have 1, second is 2, third is 4, and so forth. When we have a combination, maybe it is 4 plus 2, and we will end up with 6. So very easy to understand how the processor affinity mask is set. So let me go down. So there's one DMV, which is called DMOS schedulers, which is very important, not just for the reason of parallelism, but it's definitely worth to understand which kind of information will be visible in this view. But when I ask SQL Server about the visible schedulers, we can see that only one scheduler, which is, I make it simple, which is comparable to a core within within one CPU, is visible. All other CPUs or all other cores are offline. That means SQL Server cannot use them. We will see later on this is not, I would say this is not true. But okay, I will show this later on, because otherwise it's a little bit too complicated to understand without seeing the example. But first of all, we have just one visible online scheduler. And again, let's consider a scheduler as a core. So I will clear the procedure cache that way around. And I will go to the session again, same session as before, and execute the same query another time. So I do not need to paste this. And here we can see now we limit the number of CPUs to just CPU 3, so core 3 within my physical CPU. And the reason, so we can see it here, make degree of parallelism set to 0. I prefer to see something like 1 because 0 is not very consistent here. But okay, so we can see that this query is not running in parallel. And the reason, the non-parallel plan reason, so the reason that SQL Server will not consider parallelism is estimated DOP is set to 1. So this will give you a hint whenever you think that SQL Server should run a query in parallel. You do not understand why the query is not running in parallel. It's definitely worth to visit this property in order to understand what is the reason for that. Yeah? Sometimes it was very obvious. So I will reset everything and we will come back to a processor affinity mask in maybe 5 minutes. But again, we will start simple. So next is maximum degree of parallelism. So maximum degree of parallelism is an advanced configuration, which is set either on the instance level or nowadays also on a database level, which I really like because you can decide on a database level, maybe dependent on the purpose of the database, if you want to allow parallelism or even in which degree of parallelism. Yeah, it's pretty nice. So let me reset everything just to make sure that everything is working, because otherwise I'm really in trouble. So, and just to check whether SQL Server is configured in a way SQL Server is set up. So maximum degree of parallelism is set to 0 by default on the server level and for sure the database level. It is important to understand that the database will inherit the server settings, but you can always override the DOP on a database level. It means when you have a server maximum degree of parallelism set to 4, and you have more than 4 cores, definitely, because otherwise it will not work. You can even go to the database level, and just for this specific database, you want to override the instance level to, I don't know, 2 or maybe 6. It really depends on the use case. So let me go down. And again, I will go to the other session here just to execute the same query another time. And it is not very surprising that we will see another time an execution plan with parallelism in place. And we use all 8 cores. So let me change the degree of parallelism to 1. And when I go back to the same execution, to the same session, not execution, again, we will see that the maximum degree of parallelism is set to 1. That is the reason why SQL Server will not consider parallelism. And again, the degree of parallelism is set to 0. So again, I would see a 1 instead, but okay, I do not want to be picky. Yeah? So perfectly fine. We can, and again, this is definitely something which is very handy. When you want to avoid that, when you understand that parallelism is not always a good idea in a OLTP system, but maybe some of your queries will definitely benefit from parallelism, it is worth to consider setting a maximum degree of parallelism for your OLTP system, maybe 1 to 1 to 2, or maybe to 4, something we need to figure out, depending on thread pool starvation and CX packet and so forth, something which we will see later on. But if you think it definitely makes sense to enable the, I would say the benefit of parallelism for a specific query, we can hint the query to use more than one, in our case, more than one CPU, or we can override, make it simple, the instance or database settings. So the query hint will always override the database and the instance level DOP. So when I execute this query, it is not very surprising that we will see another time parallel plan, because we override the maximum degree of the instance level. Okay, cool. I will go down. I guess I can skip this. Just want to make sure that housekeeping is working, because otherwise I'm really in trouble. So I hope I set everything back, or reset everything. So what is the resource governor? As already mentioned, this is a very handy feature. And but honestly, or unfortunately, it is only available in the enterprise version. The idea is that you can set up a so-called resource workload group in the resource pool, where you can assign specific CPU, memory grant, and also degree of parallelism. Let's consider the following. You have a specific connection, or maybe you have a specific, I would say, time over the day. Yeah, so where you want to limit the use of degree of parallelism because you have to handle very expensive background processes. Maybe you want to import some data, maybe you want to process some data, or even in a busy system, you want to ensure that only specific users with a specific connection can benefit from the use of more than one core, because it makes sense for the specific query. So how can you achieve this? So what we can do is we can do the following. We can use, or we can create a resource pool and a so-called workload group. And within the workload group, which is now assigned to the pool, so we can have more than workload group assigning to the same or using the same pool. Within the workload group, we can define the maximum degree of parallelism users. So here we can see the degree of parallelism is set to 2. So I need to reconfigure the resource governor because otherwise it's not working. Then I can create a so-called classifier function with schema binding for sure. And here we can define whatever. I mean, we have some limitations, but again, it is either a specific username. So in my case, I'm using a specific login name, which is limited to DOP2, or maybe it is, I don't know, a specific time or whatever. I just want to give you an example. So I will apply the classifier function so it is used by the workload group, and I will create a login and use this login in another session. Change connection. No, sorry. No, I don't know why this is. It's always going back to 3. What we can do here is, and by the way, I will give the user the sysadmin role. When I execute this query just to check what kind of permissions the user, or what kind of, this is not permission, it is about configuration, the user will have, because the user is associated to the workload group, which has the maximum degree of parallelism, which is set to 2. We can see it is limited to 2. So that means when I execute this statement here in the session, which is currently used by the resource governor because of the specific login name, you can see I'm using, or this session use the workload group, my workload group 1. Again, this is the one which is limited by max DOP set to 2. So when I execute this query now in this window, we can see that the execution plan, and I will discard the results another time because otherwise it takes ages. Time we do not have. So we can see here that the query is executed in parallel, but with the degree of parallelism which is set to 2. This time we do not have any hint why this query is just using 2 instead of 8 cores, but we know why, because we use the resource governor. So there is another view which we can use in order to see maximum degree of parallelism for this workload group, and the effective maximum degree of parallelism is set to 2. Now I will, and this is a bug, I guess. Now I will redefine the workload group just to use 1 core, and I will reconfigure the resource governor to apply the change. And I need to disconnect and connect another time, because only then the new resource governor its definition will work. When I execute the same query another time, we can see something. Yes, we can see something interesting. So even though the workload group can use only 1 DOP, 1 core, we can see a parallel plan. But this is not the truth. We can see that the maximum degree of parallelism is set to 0 another time. So it is running in serial, and I guess that is a bug. So from an execution plan, we see a parallel plan, but actually we have just 1 thread, means we do not use parallelism. something you have to aware of. Otherwise, I definitely like Resource Governor for several reasons. And by the way, we can check that the query was running with just one DOP, but this is only working from the DME perspective. Okay, perfect. Let's do some housekeeping here. Resource Governor, oh, sorry. I need to close all sessions because I cannot drop everything when we still have a connection. Because it is, okay, that's fine. So because this one was already deleted. Sorry, I guess that's better now. Okay, cost threshold for parallelism. And here we can see that parallelism has its own overhead. So just to check whether cost threshold for parallelism is set to 5, which is default, perfectly fine. When I execute this query in another session, and I will open another session just to avoid that maybe the resource governor is still in place. I mean, I dropped this one, but who knows? So what we can see here is not very surprising because we limit the query to use just one core. This query has its own estimated subquery cost, which is 29, which is definitely higher than 5. So that was a cost threshold for parallelism I set on the instance level. But because of the hint maximum degree of parallelism set to 1, we will end up with a non-parallel plan. Perfect. So, but when I execute the same query another time, this time I do not use the hint, and therefore SQL Server considers to use a parallel plan instead. Because again, there is no hint, and this time we will end up with 8. Degree of parallelism is set to 8. Perfectly fine. So what we can see is the following. I will clear the procedure cache here and will run this query in another window. It's a more complicated one, which takes longer to compile. And we know that part of the query execution time is compilation time when there is no plan available in the procedure cache. So, but we will start simple. So this one was executed, and there's or I would say one specific query trace flag, which is 8675. And we can see something interesting. So, okay, this is not working. Interesting. This works. So SQL Server have, so whenever SQL Server have to optimize, or even, first of all, it will create and optimize an execution plan before query execution starts, because otherwise query execution cannot start. Without a plan, it will not work. SQL Server will go through, depending on the cost threshold, or the estimated cost of the query. And there's also a time limit, which is assigned to every so-called optimization phase. So we will end up with 3 optimization phases, starting with 0, then we have 2, 1, and then we have 2. In search phase 1, which we can see here, by the way, it is again 0 based. Yeah? So let's call it search phase 0. This is just to make sure that specific rules are applied in order to optimize the query. Okay, in search phase 1, SQL Server will consider parallelism the first time. Because again, the cost threshold, or the other way around, the query is still too expensive, and therefore SQL Server will spend a few other CPU cycles to optimize the query further, with the intention to lower the costs. Yeah, it's always a balance between compilation time and estimated subquery cost. Again, very dependent on your cardinality estimation. So, and we only see search phase 0, search phase 1, and because it is still too expensive, another search phase, which is called 2, so another optimization. And consider that I hint the query to not use more than 1 core. That means SQL Server will never ever consider parallelism. So when I execute this, I need to bring it down a bit. Okay. When I now ask the procedure cache for the compilation time, you can see that SQL Server spent 59 milliseconds on the compilation of this expensive query. Okay, and hopefully it works this time, because I don't have a good feeling about the high value here. But if it is not working, believe me, it's still true. Sometimes not very deterministic. So I will clear the procedure cache another time and will execute the same query another time, but without the hint. So that SQL Server can definitely benefit from parallelism for this very, very complex one. And you can see we have parallelism in place. And we will end up, and again, I need to blow it up because otherwise you cannot see anything. Why is it not working that way? So, okay. So this time we have what is it here? The optimization phase 0, we have 1, and another time we have the same optimization phase, which is 1, and for sure we have 2 as well, but only once. So, and as mentioned, in optimization phase, call it 1, again, it is 0 based. Yeah? So SQL Server considers parallelism. That is, in this optimization phase, SQL Server will create one plan which do not use parallelism, and create another plan which considers parallelism. And in the end, you can see that the cost, this is a parallel plan here, that is the serial plan. I mean, the costs are down, yeah, but is this really worth to spend more compile time and more CPU time just on having a bit more, or the other way around, to have a cheaper plan, just a bit of it? I don't know. We will see this later on. It is not, sorry, it is not a very good idea. Okay, so when I ask the procedure cache another time for the compilation time, okay, and this time, believe me or not, I already was, yeah, I think normally it should be the other way around, right? And believe me, when I execute the example several times, you can see, because, and I mean it is a logic, right? Because of the additional execution phase, it is still the execution phase 1, but we have 2 iterations for the serial and another time for the parallel plan. The compile time is higher. So normally we will see something like 15 milliseconds for with the hint, yeah, where SQL Server cannot use parallelism. And I mean, compile time of 22, sometimes 39 or whatever. So at least we can see that SQL Server have to do some work in the background to create a parallel plan. Yeah, keep it simple. It's not for free. So let me go down. So sometimes you wonder why SQL Server is not using a parallel plan. And I do not want to present this execution or this example. Just want to make it very simple here. But there's a specific query trace flag, which you can use since a while, which is 8649, which forces SQL Server to use parallelism even when the plan is too cheap, or for several reasons, SQL Server will not consider parallelism, which is sometimes very handy to understand what is the root cause, why SQL Server is not using a parallel execution plan for maybe this expensive query. So there's an alternative available, I think, since SQL Server 2016, which is use hint enable parallel plan preference, which is exactly doing the same job as a query trace on, but maybe a little bit easier to remember because, yeah, there are a lot of query trace or trace flags, and it is hard to remember them by heart, right? Okay, now let's go to the processor affinity mask. The problem is the following. I have my process monitor open, or the resource monitor to be precise. So this is the CPU allocation. I will use AdventureWorks another time and set the processor affinity mask to auto. I mean, this was already the case, but again, I need to make sure that everything is working from scratch and all settings are right. So cost ratio for parallelism, this time I set it to 50 on the instance level. Just want to check it. Perfectly fine. So when I execute this query, and this is really, really crucial to understand. So I do not have a processor affinity mask set, but I have a hint. You can see the hint, maximum degree of parallelism is set to 1. Let me execute this one and open the resource monitor for you. There's something interesting. Even though, you can see it here, even though we set the hint maximum degree of parallelism to 1, there is, I would say, some kind of a balance between all CPUs. That means all CPUs are busy, even though we hint the query to use just one core. So that means SQL Server has its own operational system. It's a non-preemptive one where we have a scheduler and a quantum, which is 4 milliseconds, and there's a lot of we have a suspended mode, we have a runnable and running, and so it's a little bit more complicated. But make it very simple. So we have SQL Server has its own operational system. So, and we have something which is called a logical scheduler. You remember DMOS schedulers, the one which I already presented in the very first beginning. So when we do not set a processor affinity mask and we hint SQL Server to use only one core on an instance, on a database, or even on a query level, SQL Server can still use all cores and can move one scheduler to another CPU. Maybe the CPU is busy, right? So this is under control of Windows and SQL Server. It is definitely nice because when one CPU is very busy and it is blocked, otherwise we will run in a blocking situation when by chance we hit this CPU and this CPU is busy. Then the query cannot be executed because the CPU is busy with another process and the query, SQL OS, has to wait until the CPU becomes idle. So let me execute another one. I will skip this one. This is, I mean, everything is interesting, I find. But again, let me execute the same query without the hint. That means SQL Server can now allocate 8 cores, and we will see a complete different behavior. This time, also all CPUs are heavily busy, but they are more busy than before because before there was one scheduler moving across all CPUs. And this time we use 8 schedulers on 8 CPUs. That is the reason why we can see that all CPUs are busy. Okay, so when I now hint SQL Server to use just 2 cores with the processor affinity mask, so only 2 schedulers are visible. Here, this one and this one. So, and if I now execute the same query another time with a hint of maximum degree of parallelism, you remember before the scheduler can move across the CPUs to balance the workload. Let me execute this example another time. This time we can see that only CPU, 0 and or 1 and 2. It's pretty hard to understand here, to see it here, but there are only 2 cores very, very busy. Yeah? And again, we can use also DMV, where we can definitely see the allocation of the CPU. But again, so once we have the processor affinity mask set, SQL Server will assign the scheduler. In this time we have 2 schedulers, which are assigned to 2 CPUs, and they cannot move across the CPUs anymore. You can see it takes much longer. It takes much longer because of the allocation and the assignment of scheduler to CPU. When I now execute the query another time without the hint, you remember that before all CPUs were busy without the processor affinity mask. This time we can see that only processor 1 and 2, the one we defined and only visible, are busy. All other schedulers cannot, or the other schedulers, or the other CPUs cannot use because the schedulers cannot move to the other cores anymore. And that is something you have to understand. Whenever you set your processor affinity mask, I would say you benefit from a trace flag, which is 80002. It's not 1, 002, which allows SQL Server to move schedulers across the processors, even though you set the processor affinity mask, to avoid this kind of blocking situation. Because again, what can happen is that another thread will go to CPU 1 or 2. So that time, this CPU is completely busy. So, and because the scheduler cannot move to another CPU, which is available 3, 4, or whatever, it is blocked. You run in a blocking situation by CPU contention, something you want to avoid. Something you can avoid with setting the price flag 8002. You have to reset SQL Server to make it happen. That is the reason why I do not want to present this, because it takes too much time. So let me do some housekeeping here. So also to understand parallelism, I think it is definitely worth to talk just a bit about NUMA nodes. And you know that I would say modern architecture, CPU architectures completely supports NUMA and not UMA architecture anymore. So we have one CPU with, in my case, 8 cores. We have another CPU, another physical CPU, or it can be even a soft NUMA, which you can configure, and SQL Server configures it nowadays automatically dependent on the number of cores within a NUMA, which are available. But let's make it very simple. We have one core, we have 4 cores, we have 4 CPUs with n cores. The problem now is why it is so worth to think about or to set the right maximum degree of parallelism. Consider the following. We will set the maximum degree of parallelism to 0, which is the default. Whenever you set up SQL Server, and even in Azure Managed Instance, it goes with 0. That means SQL Server can use all CPUs and all cores, but there is definitely a caveat. The problem is that once you have to exchange data between the physical NUMA nodes, there is a bus architecture, and the bus is definitely a very slow piece of architecture. So when you do not allow a SQL Server to use more than one physical core and or CPU and just use the cores within one physical core, within one physical CPU, sorry, I mix it always up, I don't know why. But again, we have 8 cores within one CPU. SQL Server cannot use, and there is no need to use the bus. There's only an internal cache which can be used to exchange data between the cores within one physical core or within one NUMA, which is definitely much, much cheaper. So there is, let me go down here a bit. There is one tool which you can download for free, which is called coreinfo.exe, which where you can monitor the latency between the physical CPUs, or I would say make it very simple, between the NUMA nodes. Yeah. So 0 to 1, 0 to 3, and so forth. So all kind of combinations which we have will be monitored. So the latency will be monitored. And I did it on a VM in Azure. And you can see I had 2 NUMA nodes available. So 2 CPUs with, I guess, 8, yeah, we can see it here with 8 or even more. But the most important one is the latency. We can see that when we exchange data within the same NUMA, we do not have a latency. When we exchange data from one NUMA, from NUMA 0 to 1, we already have a latency of 30%. I mean, this is already a big bottleneck just on your CPU, just because of using parallelism. So that is a trade-off on a CPU level. So, and that is why you always have to consider very carefully if it is worth to implement parallelism, because on your CPU architecture, you're using the bus in order to exchange data between your NUMA nodes. And this can take much, much longer. So let me go down. So in SQL Server 2000 and, oh, I need to cheat. I didn't remember this anymore. In SQL Server 2016 and plus, there is a new, called guideline. So comparing this with older versions of SQL Server, we can see that there is a difference. So what I would say comparison or the guideline will tell you is, so what is the recommended degree of parallelism depending on the available NUMA nodes or cores within a NUMA node? So we can see that there's one change. So before it was always keep it maximum to 8, or the number of cores within a NUMA. So that means when you have 16 in SQL Server 2014, 16 cores within one NUMA, the recommendation was use 8. So now it changed. We can, the recommendation is when you have more than 16 logical processors per NUMA node, keep maximum degree at half of the number of logical cores per NUMA node with a maximum value of 16. That means the implementation or the changes on SQL OS makes it make it possible to use more cores within one NUMA than in older versions, because data is growing over time. That is the reason why, you know, that SQL Server is not a pure OLTP system anymore. It is also used for data warehousing. Data warehousing, we have a lot of high number of rows, the other way around, a high number of data. And therefore, for column store indexing, indexes or whatever, there's definitely a benefit of using more than one core, so to have parallel plans available. And that is the reason why when we have a mixed, let's call it purpose or environment of SQL Server, a mixed workload, maybe that is a better word, SQL Server can now use 16 cores instead of 8 cores, which again can be very beneficial when you have very expensive query, which is most often the case when you have data warehouse queries, which are now mixed with OLTP queries, right? So there is not always a use to or a need to create a data warehouse. I mean, you can run in-memory OLTP or a column store index even on an OLTP system. And I guess when you do it right, I do not see the reasons every time to create a separate data warehouse. But again, that is something Microsoft implemented and it works pretty nice. So what is about execution time? So what I did is I used the tables which I created before, and I do not want to execute this example because it is more interesting to see the findings. But the idea was to use this query over and over again, but with different maximum degree of parallelism hints. So one time the query can use only one DOP, another time 2, 3, and so forth. And what I did is I executed the query query by query and measured the so-called wait stats. So that is the reason why SQL Server is waiting. And we will end up with the following nice Power BI report. So we can see it from here. So on the left-hand side, we can see that whenever or when the degree of parallelism, so which is used within your parallel execution plan, is increasing from 1 is not a parallel plan, it is a serial plan, but to 8, we can see that the CPU time, the CPU time is for sure growing. The elapsed time, I mean, who cares about CPU? I mean, the user do not care about CPU. He wants to have the queries as fast as possible. I mean, as a guy who is responsible for SQL Server, I see it from another angle, I would say. But from a user perspective, again, who cares about CPU? It is, I would say, often I heard, okay, let's scale up the instance and use more CPUs and everything works pretty fine. No, you can see that even when you use more cores in your parallel execution plan, SQL Server will spend more and more time on your queries. That means the user experience is not the same when you enable parallelism. That means there is not even a need to scale up your instance by making SQL Server or to allow SQL Server to allocate more CPUs. This is exactly the other way around. What is the reason that the elapsed time is growing over time? Because of the coordination. I already mentioned that there's a coordinator thread called thread 0, which have to coordinate all threads which are running in parallel. And the more threads are running in parallel, the more complicated the coordination is. And the time it takes from the first parallelism, that's bad. How can I put it? the time it takes for the first operator which runs in parallel until the last operator, which is always a gather stream, yeah, to collect all threads from different threads, yeah, to one big thread, yeah. So that is a so-called gather stream. So this time is measured as CX packet, class exchange packet. There's nothing, again, nothing wrong about CX packet. I have read so many blog articles. They tell you CX package is wrong. Something you have to do something. No, it will just tell you that your queries are more expensive than your cost threshold for parallelism, which is in my case set to 5 or 50. I didn't remember anymore. And because of that, SQL Server considers parallel executions or a parallel execution plan. And now you can either increase cost threshold of parallelism to reduce the number of plans which are even more expensive than your cost threshold for parallelism, or the other way around. I think it's much better to find an appropriate index strategy, or maybe rewrite your query. So there's so many ways to make your query cheaper, and it is not just by increasing your cost threshold for parallelism. I mean, that makes no sense. Yeah. So, and again, there is another weight type which is called CX consumer since 2016, which just monitors or measures the times from a from a consumer perspective, because a parallel operator always have a consumer and a producer. So the producer is the one which produces the row, and on the end you are waiting for the rows, which is a consumer. These are the consumer threads. And before it was very hard to judge whether it is a problem of parallelism caused by the producer or by the consumer. Most of the time you will wait and you have to react on CX packet, but not on CX consumer. And I will show you when it is worth to think about reducing CX packet. Let me go down. Coordinator threads. Actual, yeah. So make it very simple. We will start with an example here, and I know I have 8 minutes left. So at least I'm aware about my time, which is again not sufficient, but okay. Maximum degree of parallelism or cost threshold, yeah, maximum degree of parallelism is set to 0. So SQL Server can use all cores. Cost threshold for parallelism is 5, which is the default. So whenever the plan is more expensive than 5, we will end up very likely with execution plan. I will create, or I created the heap already, reset the wait stats. And I will run an explicit transaction here and update one record from the table I previously created and leave the transaction open. So now I will go to another session. I still have one open and execute this one. This is waiting. It is waiting forever because we will end up with a locking blocking situation. Let me do the following. This is a session which waits. And we can see it here. So this is another perspective on the execution plan. There's a very nice DMV which was introduced. Sometimes in some of the blog articles I read about it. It's DMX query profiles. So here we can see the execution plan and the current state of every operator within the execution plan. So, and we can see that all operators, and it starts with node. It starts with a table scan, a sort, right? And when we go down, there is one scheduler, and you have to understand that one scheduler is responsible for the entire thread within the parallelism, right? We can see a sort and a table scan, and we can also see a sort and table scan, and both operators. The same scheduler is waiting for a specific resource, which is log_m_s for shared. So this session wants to read data, which is currently updated in another session, which is by with the standard transaction isolation level, which is read committed, not allowed. Otherwise, we will end up with dirty reads. Something which is not possible in the default transaction isolation level. So we can for sure use SBO2 to see that we have a blocking situation somewhere. Here Here it is. So we have a blocking situation. This one is blocked by this one. So what happens now is when I go to waiting task, and waiting tasks are only available when the query is still executing, we will see that we will end up with a lot of CX packet wait type. But this is not the problem. The problem is that one thread within your parallelism is waiting for an incompatible lock. That is the reason why your CX packet wait time is growing and growing and growing. Remember this one, 616? I will execute this another time. So the wait duration is growing. And now when I roll back the transaction, immediately this one is finished. And now for sure waiting task is not available anymore, but we can use wait stats. And when we see a combination, and that is a key here, when we see a combination of CX packet with something like LCK for log underscore M, I don't know, underscore S or X or whatever, that is an indication that we will end up with a locking situation. And that is the reason why we will end up with a very high CX packet. But there is nothing I can do by increasing the degree of parallelism, or I don't know, increasing the cost threshold for parallelism. Yeah, it will not work. Nothing I can do here. The only way is to consider, I would say, optimistic concurrency, maybe read committed snapshot isolation, yeah, which allows reading data which are currently updated because it uses the version store of the tempdb, or maybe using in-memory OLTP even to avoid that writers can write block writers, right? So I have 4 minutes left. That's perfectly fine. And I will not go through the example, but I will tell you two things, because in 3 minutes I cannot demonstrate thread pool starvation. But thread pool starvation, now you understand that the more, or the other way around, we have only a limited number of maximum worker count available, which is depending on the number of CPUs. There's a formula behind. So we are, my current installation of SQL Server only have 576 maximum worker count available. It means when I reach the number of maximum worker count by running more and more queries in parallel, it is very likely that we will end up with a situation that there is no worker count available. There is no worker count idle to take up the work from the task. So the task is waiting in front of the schedule for an idle worker count, and this is called thread pool starvation. So whenever you see in your wait stats thread pool in combination with CX packet, thread pool in combination with CX packet, that indicates that you really have a serious issue, because you have a lot of very expensive queries, more expensive than your cost threshold for parallelism, and therefore they're running with all available threads. And now you have to understand the following. When I have 8 threads as a maximum degree of parallelism, it depends on the operator. For example, a merge join, or the other way around, a hash join has a so-called build and a probe phase. So we will end up with 2 threads here. That means the query will end up with 2 times 8 threads. A merge join can allocate even 3 branches, and every branch can allocate 8 threads. That means a merge join will allocate 3 times 8 threads, or 8 worker counts. That means the more branches you have, the more it is likely that you're running in a thread pool starvation. And I have 1 minute left. I will tell you the following, and that is what was completely new for me. SQL Server will reduce the usage of DOP, so the usage of cores, in flight. So that means when SQL Server understands that there is a CPU pressure, because a lot of other queries are running in parallel, and the maximum or the available worker threads are not sufficient anymore, or it's very likely that they become insufficient, SQL Server will give queries not 8, but just 2, or even just 1 DOP, so degree of parallelism or cores, fully automatically. this was really, really nice to see the internal algorithm which is in place to avoid thread pool starvation. This is not a guarantee that thread pool starvation can be completely eliminated. But again, with SQL Server 2019, it seems that there's a new algorithm in place, which at least reduces the probability that you run in thread pool starvation. But again, it is on you to figure out the queries which are running in parallel, tune them to make them cheaper, to avoid parallelism in an OLTP system. That's it. I'm in time. So let me go to the chat window to see chat. Questions from yeah. So okay. So how to determine cost threshold for parallelism? I mean, it's very, very complicated to understand. So there are several guidelines available. Sometimes they do it with the average of the cost threshold for parallelism, or with the sub-tree cost of each query. And I mean, this is not very practical, I would say. So I would say whenever you do not see thread pool starvation, you can decrease the cost threshold for parallelism to benefit from parallelism when you're in a data warehouse scenario. When you are in an OLTP scenario, it's completely different, because you have to understand why a typical OLTP query is running with more within one thread, because this is not very common. So therefore, to answer this question is very, very difficult, because it depends on your environment, it depends on your workload. Question from delegate: why maximum parallelism is set to 64? I mean, yeah, why parallelism is not set to 8? Because exactly of the reason that within a NUMA node, it's very unlikely that we have more than 64 cores. And again, taking into consideration that SQL Server, or not SQL Server, Microsoft now has this guideline in place where it is recommended not using more than 16, which is already 2 times more than before, which was 8. Yeah? So, I mean, the use of 64 is such an overhead that the use of more and more cores will, how can I put it? The other way, have a negative effect. So all your queries are getting slower, and you can see it. You can see it here, for example. So more DOP. Now you consider I'm running with 64 DOP. So I mean, my entire system is busy just to execute one query. Again, very likely that I run into thread pool starvation without any benefit. And thanks a lot for joining my session about parallelism. Thanks for the invitation another time, and I hope to see you next year. Again, thanks for organizing the event. I know it's a huge amount of work. I cannot even imagine. So therefore, I really have to say thank you to the organizers and to the sponsors as well.